G'day, it's Mike Walker from FlexRadio, and welcome for the QSO today for September 2022. Today, my guest is none other than Steve Hicks from FlexRadio. Steve N5AC is the Chief Technical Officer and Vice President for FlexRadio Systems. Hey, Steve, how are you?
Good. How are you doing, Mike?
Good. And we've had Steve on before, and I've asked him to join us again, and he's going to, I guess, do us a big favor. We did a presentation at Dayton, and some of you may have seen it, but the rest of the world may not. So I've asked him to run through it again, and we've refreshed it. And I'll give you a warning. We're recording this in early August, so it's possible that things, by the time you see it, might have changed a little bit, but I think we're pretty stable for the next while. Steve, you've been a busy guy. We got a lot of stuff going on, and so why don't we'll get started in your presentation, and we'll bring it up here, and whenever you're ready to go.
All right, sounds great. Thanks, Mike. I appreciate all y'all for showing up for QSO today. It's been a great event for us, and we really enjoy talking to all of our customers in this format because it gives us an opportunity to reach out and contact people who can't travel or with COVID going on and all that sort of stuff. So, all right, well, here's a little bit what I'm going to talk about. I'm going to talk about what we've been up to as a company, a little bit about the Flex 6000 history and where we're going with it. I want to talk a little about supply chain. I'm sure a lot of you have heard, if you're not directly involved in supply chain, you've heard about some of the issues. And I think it's an interesting topic and help you understand some of the challenges that we face. So we'll talk a little bit about that. We've entered the broadcast amplifier business as well. And so I'd like to show you some of those, mainly because, everybody likes seeing QRO equipment. And then talk to you a little bit more about our software and hardware. So as many of you may know, we've been investing heavily in our U.S. government contracts, and they've made it difficult for us at times to invest as much in amateur radio as we want. They've kind of sucked up a lot of our people. That's good and bad. There's good news there. The good news is that the people that have been working on that have been learning a lot of new skills and new technologies, which we can bring to the amateur market. And we've also grown our staff sizably, which I'll show you here in a minute. But in spite of all that, we've grown our amateur sales year on year, and I want to talk a little bit about how we got here and how that's working out for us. So the initial Flex 6000 we introduced back in 2012. We introduced the 67 and 6500 together, and then later came out with the 6300. As we worked with these radios, one of the things we realized is that we wanted a more modular platform, and so we migrated those to the 64 and 6600. We do still sell the 66 or 6700 because it has a lot of capabilities that are not there in the 66 and 64. Namely, it has a 2-meter IF in it, and it also has 8 receivers and 8 pan adapters if that's something that you need in your application. Some of the other things that we added were a front panel option. So we have in the 64 and the 66 what we call an M series that lets you put the Maestro-like display and knobs on the front of the radio. So you can buy the radio with or without that. And there's a lot of expansion area in this radio to do new things in the future. In the 6600, we also added contest filters, which have been a real boon in contesting, as well as the capability of doing SO2R in a single box. And that allows you to run one radio and one SO2R amplifier as if you had 2 radios and 2 amplifiers. So it really substantially lowers the cost of entry for someone who wants to try SO2R contesting. All right, to get a little technical here, this is the main CPU board of a Flex 64 or 6600. They use the same base CPU board, but there's a couple of things we did to this that we didn't have in the 66 and 6700. In the left there, you can see a square around something that looks like 9 little gold patches, and then in the lower right, there's a larger gold, funny-looking shape there. And so I want to talk about what those are. If you look at the amount of bandwidth that we have that we move from the radio out to your client or somewhere else, if you're just streaming audio from your radio, it's not very much. It's 70 to 200 kilobits worth of audio. That's something you could run over an ISD line or even a cell phone line that's challenged. But as you go up and decide that you want to run a couple of pan adapters, audio, and you want to do DAX over this, which sends unadulterated samples from the radio out to your client, so that it can decode things, we're working upwards of 20 megabits worth of data. And so this is a picture from the original Flex 6000 architecture diagram. And you can see we have the ADCs there, which are the kind of look like rectangle shapes with a triangle on the end of them. Those pump a lot of data into our FPGA, which then used to send it directly through our baseband processor. And it has a limit of around 100 megabits a second that it can process. So what we did in the 6000, that first little picture that you saw that showed the, I can bounce back there real quick, but showed the, this shape here that has the little 9 patches on it, we placed an Ethernet switch in the radio. And that allows us to pump up to a gigabit worth of data out of the system. And that's been a really interesting thing for us and has allowed us to do some really unique applications. One of those is we've been working with a top 10 university on a life sciences application that they're actually using Flex 6000s on to do research and develop a new piece of equipment. So it's a really exciting thing for us. And in that piece of equipment, we're running 4 3 megabit streams out of the radio, which is 865 megabits a second, which, your radio off the shelf has a lot of the capabilities to do. It doesn't have all the software to do this, but we put this in here for future expansion. The other thing that we did was this other shape that you see on the circuit board, and this is a space for a very high technology DSP modem. And the modem that we chose to go in here, which we chose before the introduction of the 64 and 6600, does mil standard waveforms. The top one is the mil standard 188.110 ABD is a data waveform that goes up to 256 QAM, and the 141 supports ALE. 141D goes up to 4G ALE. So you probably heard of ALE. 2G ALE is what most hams are working with, but there's 3G and 4G. And there's a lot of other NATO waveforms in this. And that's one of the things that really got us into the military world is that we had this capability in the radio. Okay, so how do we end up here? Well, there's a number of things. One of them is that there's a lot of pressure for the military to look for other communication mechanisms. Why is that? Well, they started out using HF, VHF, UHF, and eventually migrated a lot of the communications to satellite-based communication systems. And there's a heavy reliance on satellite today for a lot of different reasons. It's accessible, 24/7. The communications are good. It has wide bandwidth because it's on the microwave bands, all those kind of things. But with the advent of the ability to shoot down satellites in having a satellite denied environment, if you want to talk around the world, HF is one of the few things that can do it anymore. And so this has made HF important again. And as that's happened, there haven't been very many innovators in HF, except for in the amateur radio world. And so HF has continued to be a big source of users in the HF spectrum and technology development. So what's old, HF, is now new again and of interest to the military. So this is the radio that the Air Force has been using, the U.S. Air Force, for many years in aircraft for HF. And this is what's called an ARC 190. It's a wide temperature range, high altitude radio, operates in a hostile electromagnetic environment. This radio has gone through about 8 revisions, and it's been built for the last 40 years. So it's very old technology. In fact, if you look inside it, you can see there's a lot of through-hole components and big electrolytic capacitors for power supplies. And even look at the integrated circuits kind of over there on the right. You can see, you probably recognize some of those if you've been in the electronics industry as being ceramic dual inline packages, or what we call DIPs. So lots of old technology in this radio. So we got a call from one of our customers who wanted to know if we'd be interested in participating. That customer actually worked for Raytheon at the time. And so we ended up discussing building an HF radio together with Raytheon and decided to do that and entered a contract with them. And so this was the announcement when it came out on the ARL website. And so here's kind of the details about what this contract is all about. FlexRadio is the design authority and is responsible for all aspects of the design. So it is a FlexRadio product that is built and that will be placed in the aircraft. And BAE, who ended up, well, mid-contract, Raytheon got acquired, and they sold off this portion of the business to BAE. So BAE is now the contractor that we're working with. But they're responsible for everything except for the design of the radio. So there's a lot of other things that happen in military contract other than just the design work, and they do all that extra work. So the neat thing about this is that FlexRadio owns the intellectual property that's developed during this contract jointly with BAE, and all the IP that we brought into it is owned exclusively by FlexRadio. So all the things that we've spent time developing over the last couple of years, the ones that we can, we'll share with the amateur community. So that's a great thing for amateurs. The other thing here that I put at the bottom is that BAE is the exclusive sales arm for the product. We won't be outselling this, BAE will, this radio that was built. Here's what one of the first radios looks like. It's prototype. And when we did the migration, we started with a base 64-6600 and said, what are the additional things that would be needed by the government in an airborne radio? And together, us worked with Raytheon BAE, which have 50 plus years and tens of thousands of radios in the field. Many of them are airborne, and we used their experience to help us design this airborne radio. And one of our key design requirements was to future-proof this radio and build as much technology into it as we can, because it could be used for a long time to come. So you look at some of the capabilities there, we're only using a very small fraction of the CPU and memory that's in this device. And we added a bunch of modern capabilities as well around waveform spectrum analysis, adaptive power control, all kinds of things. So very, very fancy radio. It's orange just because it's a prototype and it cannot fly in an aircraft. We've tested the radio in aircraft, but it has not flown yet in this configuration. And that's the orange is to remind people not to do that. This is the control head that we chose for the radio. It's made by a company called Avalex. It's an ACM 9433. It's a software-defined control head. Makes sense to attach that to a software-defined radio. It is an NVIS-compatible and sunlight-readable display. NVIS is not what we think of, which is near vertical incident skywave. In this case, it's for night vision. And so the requirement is that if a pilot has night vision goggles on, the display can't do anything that's going to interfere with the operation of that or blind the pilot while he has the night vision on. So in combining the old and the new, this radio speaks Ethernet, which is what we do in our radios, which is kind of the new, as well as RS-485 and a bunch of other older protocols. And so it talks RS-485 to the control head here. Just taking a look inside the radio, this is what it looks like when you flip it upside down. There's two very large microprocessors in it. They're literally the fastest and most capable microprocessors we could find to put in the radio to give the Air Force as much capability as we could. There's a module in here that houses the same kind of waveform technology that we showed you we put into the Flex 64 and 6600, FPGA board, receiver board. We also put space in here for expansion, and there's a large 400-watt power amplifier in here. So one of the things I wanted to tell you about is what technology we put in here and what the benefit might be to the amateur community if we decide to move that forward. And so the lines here that are green all the way across are ones that I think could benefit the amateur world moving forward. The ones that are that don't have the green on the left-hand side are ones that we don't think necessarily apply to the amateur world. So in the Flex 64 and 6600, we use the TI DaVinci processor, or TMS 320, and there's the actual part number. What we were able to do as part of this contract is to build, to run on two additional processor families, and they're very different processor families. And that capability got us into a mode where we're very easily able to port our base software-defined radio to lots of different other platforms, which gives us a lot of legs moving forward. We can scale it down, scale it up, whatever else we need to do. We did add a ultra-low phase noise oscillator in here that and added a capability to it that substantially reduces out-of-band phase noise. And so should we choose to bring this forward in the amateur world, it would provide a better contest capability as well as field day capabilities. We did a lot of electromagnetics protection in this radio. We had basic stuff in our radios, but we had to harden this radio against all kinds of EM challenges, including lightning. And so we believe that technology is something we can move into a radio to help build out its lightning capabilities. We also added a brand new waveform support for it. So we had a waveform API in our existing radio, but we significantly upgraded that, made it multiprocessor capable, and made it easier to add new waveforms. So we think that's something that would be beneficial in the future to hams. So if you look at our radios, the kind of max RF input to them before they begin to overload is around +7 to 9 dBm. That's about 10 milliwatts. What we did with this radio is we made it capable of ingesting 10 watts or 20 watts directly into the snout of the radio. So we don't think in general that's something that hams are going to want to do, certainly not on purpose. And so I don't know if that has a lot of applicability here. We did add from an I/O processing standpoint, we added some ancillary I/O processors in this radio that allow us to do a lot of fancy input-output on the radio. We did that because this radio carries forward a lot of legacy interfaces so that the radio can work with existing equipment. Again, this is not something we felt like was really useful for the ham community. Today, we offer 100-watt MOSFET amplifiers in our Flex 64, 66, 6700 radios, as well as external 1500-watt LDMOS amplifiers in the form of the PGXL. What we did with this radio is to put a 400-watt LDMOS power amplifier in it and integrated that into it. We do believe there's value in providing higher power into amateur radios, but we have some other ideas about how to do that in a different way than we did in this radio. So for that reason, we decided not to look at this as a technology we've moved forward. We did do a lot of environmental conditioning of this radio, as you might imagine. It has to survive military temperature, vibration, shock, altitude, all kinds of other stuff. And we did a lot of testing at those harsh environmental conditions. Again, we don't think there's a lot of value in this for amateur radio operators. Most of them are going to have these radios sitting at their house or sitting out on a picnic table at field day and not being vibrated to death on an aircraft. But again, new things that we learned. I did mention the modem that we have in the radio is now capable of doing a lot of different mil standard waveforms. Some of these are used in Mars and in other amateur endeavors. And so we may pull some of those waveforms into future amateur products for use by hams if it makes sense to do that. So we'll be looking at the market and talking to other amateurs and Mars members and trying to figure out if this makes sense to do. In fact, I have a meeting next week with some to talk about that. Let's see, clocking and timing. We did a very advanced clock system in this that provides GPS holdover. I don't think that's something that hams are really probably terribly interested in, but it's something we can migrate if we decide to do that. We also added the capability of using a bunch of different reference inputs. Today, our radios expect a 10 megahertz reference input if you want to use one. Again, I think this is really mainly benefit to the military and not a lot of ham usage. We'll probably stick with 10 megahertz as the only reference input we support for hams. Then we did a really novel RF filtering capability in this, where we went from just having receive band filters to a tracking bandpass and tracking notch filter. And so this is something that we're likely to move forward into future amateur products, as it provides some unique benefits. Before we were running on a single FPGA family known as Vertex 6. We now are running on multiple other families that are lower cost and higher performance. And so we expect to use some of those FPGAs in future ham products. And finally, the last thing we did was, if you look inside our Flex 6000 series, we're running at 24 kilosample for our baseband processing. That allows you to run waveforms that are up, or modes that are up to 20 kilohertz wide. Most hams aren't ever going to exceed 10 kilohertz, but we did add the capability of doing variable rate processing in the radio. So we can process at a number of different sampling rates, and that gives us some more advanced DSP capabilities if we decide to use them. So what is the status of this contract? We finished the initial contract prototype, delivered that to the Air Force. We were down selected as the winner of there were two competitors going for the final radio. It was us against L3 Harris. We beat L3 Harris and were selected to mature the design and supply around 1,500 radios to the Air Force over the next 5 years in a new contract. And the radio has been given an official Air Force nomenclature, which is RT-2122. And most of our work is concentrated now on this contract in the near term. We'll be finished with almost all the work on this contract by December. And then we'll have time to move on and do new things. So that kind of gives you a little background on that. I mentioned earlier, I want to tell you a little bit about the supply chain and what's going on here and what all this means to you. So as you might imagine, as an electronic supplier, we have to source all the individual components that we put into a radio. Those components get placed on a circuit board. The circuit board gets assembled. We put them into radios, write the software on them, all that kind of stuff. And there's a wide variety of components that we source. They're everything from resistors and capacitors, passives, if you will, to advanced integrated circuits like processors and FPGAs and those kinds of things. And COVID is like has been like somebody throwing a stone into a pond, and the ripples kind of keep coming. And we're, parts that usually we could buy off the shelf at any number of places now have just vaporized, and we're told we can't have them for 6 months or a year. And so we've had to be very aggressive about figuring out how to manage that supply chain and in cases redesign when parts have become unavailable. And so that's been a real challenge for us. It has occupied a lot of our time as well on the amateur side to make sure that, we have all the components that we need to build radios. We've also moved most of the management of components inside of FlexRadio. Before we had left some of that with our contract manufacturers, so we've moved most of it inside now. This slide just gives you an idea of what this is like. One of the key parts we use in our radios is a field programmable gate array, or an FPGA. And if you look here on the left, in July of 2020, the lead time on that component was 12 weeks. So it took us about 3 months to get the component, and the price of that component shown on the right-hand side, let's just call it 1. And you can see what's happened over time, that the lead time, which is the red line, has moved to around 78 weeks. So that's, well in excess of a year that it takes us to actually get a part now. So we place an order, over a year later, we actually get the part, and the price has escalated from, 1 to 1.5 or 1.45 or whatever. So the price has risen by 45%. So, this kind of thing's happening all over the electronics industry. And so it's required us to be much more careful about how we buy and manage our parts. Okay, I mentioned we'd entered the broadcast amplifier business. This is a pallet that we use in a larger amplifier. This is a 1.5 kilowatt LDMOS HF module that's designed to run, brick on key. It's based on two 1800 watt 65 volt transistors. It's very high linearity to support multi-carrier waveforms. And we take 4 of these modules that look like this and combine them together to make a 4 to 5 kilowatt amplifier, or we combine 8 of them to make an 8 to 10 kilowatt amplifier. And so, like all of our products, it uses Ethernet for communications, control, and monitoring. It's a very modernized amplifier in many respects. It uses LDMOS as well as its communication and management capabilities. This is what a rack of the equipment looks like. On the right, you can see the 4 modules. In the middle of them is a combiner. We have a exciter on top and a control system. And over there on the left, you can see that's Gerald, our founder, K5 SDR, and he's standing next to the dummy load that we use. I think this dummy load here is a 10 kilowatt dummy load. This is a look inside, showing you a couple of the pallets that are inside that 1500 watt amplifier. And you can see the huge heat sinks on the back of these that support the amplifier. This is what the low pass filter module looks like in this radio. I put a banana here for size, so you can see how large these components are, because you have to pass 1500 watts through these. And there's a variety of bands, of course. It's not just amateur bands. This is the back side of that board. And there's some expansion space here if we want to go up or down in frequency as well. So we've had all this success in military and commercial amplifiers. Why continue amateur radio? What would be the rationale for that? Well, there's a lot of them. We love designing and building products for amateurs. All the people that started the company and many of the people that are in the company are amateur radio operators. And we love amateur radio for many, many reasons. We just love amateur radio, of course. We also believe in it as a way to excite, train, and etc. The young in our country to be interested in RF, to grow up to be RF engineers and understand RF. We have a lot of fun dreaming up amateur products and new software. So this is, for us, a lot of the fun of the business. And of course, we love our customers. I don't know if you know, but FlexRadio, one of our key tenets is that we exist to enrich lives. And so amateur radio is one of the ways that we do that. We enrich the lives of our customers that use our products and get pleasure out of using them. And so that's a key thing for us. This is one of the reasons we take on business like the life sciences project I talked to you about earlier at a university. That's not a project that we're going to make a lot of money on, and it's distracting. At the same time, it's something that we believe very deeply in, and we believe has a huge societal impact, and that's why we're involved in it. Of course, we came from the amateur market, and we're committed to the future of that market. So what's next for FlexRadio? Well, if you look 3 years ago, before COVID started, we had 6 engineers. Today, we have 20 full-time engineers and 7 contractors, most of which are full-time with us as well. And we're hiring additional engineers. You can imagine that going from 6 engineers to 27 is a huge deal. We grew that fast, that big, very quickly in the span of a couple of years. And we have a lot of big plans for what we're going to do with all of our capabilities moving forward. So stay tuned. We're really excited about all the stuff we've been working on and interested in showing you. So on the software front, we have Smart SDR 3.3, and it's a maintenance release. It went out a while back. I'm not going to say how many weeks or months because this is airing a little bit after I actually recorded it. But it includes over 160 individual defect fixes. We did release a point release on top of that, which is a 3.3 point release. And the team currently is focused on getting 3.4 ready. So that's the next version we're working on. And we're in the process of moving many of our engineers from working on government and other products over to the amateur side. And that transition has begun now, and it will continue and happen even more next year as we roll off our key government contract. On the hardware side, all of our top engineering team recently met offsite to discuss our hardware roadmap. And we went through that. Out of that roadmap, we ended up with 11 new amateur products and 7 government products that we want to build. In every case, a government product is preceded by an amateur product because we feel like we can bring new technology to the amateur world, see how it works in that market, refine it before we go bring it to the government market. So in general, amateurs will be the beneficiaries of new technology that we create, and then we'll offer that technology to the military. So all these products that we thought about in that offsite may or may not make it to market, but it does show you that we're thinking very actively about creating new products and what we want to do. We have a lot of new tools and capabilities as well as people that are going to help us accelerate our growth moving forward, and we're really excited about that. That's it. Anything else, Mike? I think we're going to move.
No, yeah. I wanted you to back up a couple of slides because it's sort of cute, and I know some people will notice it. Go back to the slide when you first showed the amplifier, and there was an expensive piece of test equipment sitting at the bottom. Go one more. And if you look in the bottom right, you'll see a tiny VNA, right?
Yeah.
And I know the answer to this, but I'm sure people going, really? That's your high quality test equipment? And there's a reason.
Well, we have, as you might imagine, as an engineering company, we have a lot of different pieces of test equipment. I mean, we have a phase noise analyzer that costs $100,000. And you contrast that to the nano VNA you see here, which is, I don't know, they're a few $100s, yeah. But these are very nice to use to take quick measurements. They're very portable, and we own several of them. When we do preliminary filter tuning to check things out, we use them. They're very accurate, so we enjoy using them.
Yeah, and they're not expensive if you make a mistake.
Yeah, that's right. A battery in one of them, yeah.
Yeah, so that's what Dan was saying. Well, Steve, that was great. I'm fortunate to be part of some of those idea discussions, and us on the marketing side said, "Oh, just build them all. We need them all. They're all great," and they are. But we'll see what comes out the other end around a little while.
The tough part is deciding what to do first.
Yeah, Steve presented some stuff to me, and he goes, "Mike's going to like this," and I went, "Oh my god!" And anyway, it doesn't. I'm sorry to tease you guys, but that's sort of the telling you we can get there. Steve, I wanted to thank you for taking the time out of your day. And any questions, you can email us at info@flexradio.com. Steve didn't mention much about hiring, but we're always looking for things. Like Steve, I can mention that if you want. You can email me, and I'll get the resume to the right people.
We're always hiring people, and now more than ever. And if you are interested in working at Flex Radio, you can send an email to jobs@flexradio.com or jobs@flex.radio.
Great. Let's say 73, everybody. Thanks for joining us. And Steve, have a good weekend.
All right, 73.
73.
And I'll take with the advertising. Steve, hello again.
Howdy.
Long time no see. So we'll. I think I've watched that. Obviously, I edited it, but every time I see it, I pick up something else. So, Bill asked this question, by the way, when the previous presentation, when you were covering for Matt about FS14 for RTTY.
We have the base wiring and everything in the radio to do this. We just haven't taken the time to go hook it all up. And I'm not aware of a current plan to go do that. I think the thing that really elevates features like that to the list of things that will be done is through folks like you, Mike, and Lori and the sales team. So if this is something that's of key importance, please make it known to you and everybody. And if it shows up on a list as a key feature customers want, we'll go do it.
And I'll add a bit more to that. Our community at community.flexradio.com is a great place to bring your ideas forward. It allows people to vote on them. It allows us to go mine it for votes and stuff, and just to see the requirement of the community group. So thanks for that. From John, will the DSP hardware modem be available as a retrofit for Mars operator that currently have 64 or 6600 series radios?
I don't know yet. I'm having conversations with multiple people, Mars members and SMDs about this, and discussing what we might or might not do. One of the challenges that we have as a company is the size of the Mars community, and if we believe we can bring out a product that the Mars community would embrace, that would be cost effective, I think we're gonna want to do that. So that's what we're currently exploring, is can we do that, and does it make sense, and all that. So if you have specific thoughts about that, I'd love to hear about them if you want to send me an email.
Okay. And that's Steve at flex.radio?
Yeah, that'll work.
That'll work. This is a very interesting question from John. What is the survivability of this unit during an EMP event? What protection methods are incorporated in this unit? And I think we were talking about the aircraft HF radio at the time.
Yeah, so EMP is defined under MIL standard 2169 and 464D, and tested with MIL standard 461G, CS116. I'm not going to go into a lot of detail on this, but I can say that the radio did have to go through CS116, and it passed with flying colors in its first trial in that test suite.
Oh, that's cool. So that means I don't have to keep my hot water 101 if I want to get on the air after an EMP event? Who knows? Harry, Kilo 9 Delta X-Ray Alpha, does the scope of the government project include any features that may support use by spacecraft?
The specific radio that we designed, we did for the Air Force, and it was for the primary use is in wide-body Air Force aircraft. And so what you read into that is things like tankers and bombers and large aircraft, and not things like fighters. There's no discussion during that program of spacecraft use. Incidentally, there are a couple of Flex 6700s flying on the International Space Station. But we haven't done anything in this project related to spacecraft.
Okay, thank you. From Tommy, Whiskey 1 Alpha, Uniform Victor. You said you were looking at other FPGAs besides the Vertex 6. Will they still be AMD or Xilinx? Are there others that could compete?
Yeah, so the two primary FPGA companies are Xilinx and Altera. Xilinx was acquired by AMD. Altera was acquired by Intel. And so we always go out and look at Altera as a replacement for Xilinx when we go look at new families and compare the pricing and capabilities and those kinds of things. In general, Xilinx, there is a cost to switch because we have to go migrate IP, and we try and stay away from. If you look at the FPGA world, there's a lot of the vendors will provide blocks of IP that try and streamline your world and make it easier. But if you use those blocks, you kind of lock yourself in to that particular family, because when you try and move to another FPGA vendor, the blocks are different. So anyway, we try and minimize our use of those blocks and look at other alternatives, primarily Intel Altera as an alternative. And so we continue to look at them. Currently, we're still only using Xilinx. There's a new family of Xilinx parts that we've started using.
Yeah, and IP standing for intellectual property. So in case you didn't. From Harry, Kilo 9 Delta X-Ray Alpha, can you use modeling techniques to assess circuit performance of the components months ahead of their availability?
So we do now do a lot more modeling than we used to a few years ago, especially in RF filter design, those kinds of things. A lot of the components that we would use, we can get samples of to go build circuits. So let's say we want a part that's not available for a year. We'll often call the vendor and say, we're thinking about using this part. We're going to buy N number of thousands of those. If we decide to use it, do you have a sample or an evaluation board that we can use? And they will, provide those free of charge for us to go test everything out. So that's, one way that we do that. We also do modeling before we go pick components as well. But it depends on what it is. Like a power supply component, we always model switching power supplies before we go buy the component, even though we can get evaluation modules and boards and stuff. We do a lot of RF simulation. We do simulation in the digital FPGA world. A lot of the other kinds of stuff, basic analog circuits and stuff, it kind of depends on how complicated it is. If we're sure it's going to work, we won't simulate it.
Okay, thank you. Robert, November 0 Kilo Alpha, what design features will allow amateurs to maintain the new radios?
I'm not sure I understand the question.
Yeah, I wasn't sure either. Maybe, Robert, if you can ask that again, we'll get to explain a bit more. From Russ, Kilo Radio 6. Oh, back up to
go
Robert.
Back a second. I suspect this is about, if the radio breaks, can I fix the radio? I'm assuming that's what this is. And if that's what this is, we always try and select components that are easy to solder. For example, we choose leaded components. We choose SMT leaded components over BGA, ball grid array components where possible, because in our service shop, we want to be able to service them as well. So, we do things like that. Some components are only available in packages that are difficult for an amateur or even for us to go repair. An example of that would be some of the microprocessors that we choose are only available in ball grid arrays. The Da Vinci processor that we're using, for example, in our radios today only comes in I think it's 1,053 ball part, it's that part's about this big. So, and the FPGAs are the same way. They're only available in ball parts. So, there's some of those kind of things to get the capabilities. We have to use those parts, and they only come in those form factors. And so that's kind of what we're stuck with.
Yeah, good answer, especially from service. We have quite a pretty good service team as well. Is Flex/403A planning to carry any of the commercial amplifier technology described forward to the amateur radio business?
Currently, 403A is providing doing the design work in conjunction with us for products like the Power Genius. The amplifiers that we're making in the commercial amplifier world are 5 and 10K kilowatt amplifiers. So those are not things we're going to bring directly into the amateur world because amateurs can't transmit 5 kilowatts. So we don't have any plans to bring those into the amateur side of the business. I'm not sure if that answers the question or not.
Okay.
If it doesn't, ask again.
Taylor, Kilo 7 Alpha India Echo, with HF becoming a sought-after communications method again for the defense industry, how has Flex/BAE addressed the issue of jamming? As even encrypted transmissions are still targetable with their frequency space. Understand you may not be able to answer, was the rest of it.
Yeah, so there's a whole bunch of techniques in the military world for anti-jam, and I really don't know what I can and can't say, so I'm not going to say a lot. I'm simply going to say that we discussed, reviewed, and added some features to the radio that we provided the Air Force along these lines. I just don't know what I can say about any of those features or how they work, so I'm not going to.
Okay. From Ed, November 6th, Radio Foxtrot, Germany. What new military uses? Autonomous vessels, submarines, armored vehicles, lunar uses.
I'm not sure. I'm not sure what the question is.
It must be the future of what the military might be doing with the equipment. Heck, they wouldn't even tell us, would they?
Well, as you might imagine, HF, because of the reasons I stated before, HF is of interest to the military more now than it used to be. And there are requests for HF equipment across the entire military. So, it's coming in mobile vehicles, airborne platforms, Navy platforms, all that kind of stuff. So there's a lot of questions about it and bids out and all the other kind of stuff for different platforms. And we look at those as we find them and as they're brought to our attention and discuss whether or not they're ones that we want to participate in. One of the things that's interesting in the military world is that each service has their own requirements for equipment, and that applies both to U.S. and international militaries. And sometimes when you look at a particular request for a piece of equipment, there's an incumbent player that already has gone to the effort to build a lot of the capabilities in that we might not have. And so some of those opportunities we pass on just because we know we'd have to charge the military a bunch of money to build those capabilities in when a competitor already has them. So, and I haven't seen any requests for lunar HF yet, but who knows?
That's another service call you'd be happy to make, right? Right after you do the space station?
Oh yeah, sure. Send me.
How well does the Flex system play with HDMI switch boxes? Some devices think there is no screen attached if not the selected input device.
I do not know the answer to this question. The only unit today that we have that would play in this world would be one of the M series, so like a 6400M or a 6600M, because we have HDMI output on both of those radios. And I have seen people connect them to external displays, but I don't know. Do you know if anybody's connected one to a HDMI switch box or repeater?
I'm going to take the no news as good news because a properly designed HDMI switch box needs to fake out the fact that it's really there for whatever device is connected to it. Imagine 3 or 4 different sources. So going by what I've seen in the community regarding it would be nothing, has been said. And I know there are people that are switching multiple inputs. So I think you're okay. Just
yeah, I'm sorry, I just don't know. I've not tried it, so I'm not sure.
I'm staring at one right here. Keep with that input, where the 6400M or 66 would be the input. Just haven't gotten around to it. And our last question. So if you've got anything you want to ask, please ask it now. From Ray, Zulu Sierra 6 Radio Sierra Whiskey. What about the 400 amplifier built into the aircraft radios? And what about it?
No, I don't know.
Yeah,
I'm not sure what the question is there. Yeah, we designed a 400 watt LD MOS amplifier from scratch. As you might imagine, it dissipates a lot of heat, and so the actual unit itself has a lot of metal in it and a lot of heat sinks to dissipate that heat. I don't know what else I can tell you about it. I mean, this unit is designed to run at very high ambient temperatures. We have to run at least for some period of time at 71C. So there's a lot of cooling in this amplifier that would not be necessary in somebody's house. If your house is at 71C and you're able to live in there, I'm going to be real impressed. But I don't know what else to say about it. I'm not sure what the question is.
Do you know what voltage they run at? No, just in case people were curious. Do you remember?
Yeah. So
It's not 12 volts.
We have a variable supply on our LD MOS amplifier, and we can run it from, I don't know, 45-ish up to 65-ish volts, somewhere in there. And we're typically running this one around 48 to 50 is where we get the best performance out of it.
I think that's it. Steve, again, thank you for taking out part of your weekend. Everybody else, I want to thank you for taking the time to join, and we hope we provided you some useful information. And if you want to reach out to any of us, we're always looking for talent jobs. I think at flex.radio, jobs at flexradio.com if you're in that technology. Any other info, you can send it to me at info@flexradio.com, and I'll get it to the right people if I can't answer it myself. So we will say 73, everybody.
All right. Thanks, 73s.
Take care.